Our next chapter is actually an entire chapter about exponents. We're going to start with some properties of exponents. Now, you'll find that these seem like they're going to be really easy, but just be really careful as you're doing these problems. I get a lot of people making mistakes through them, so make sure that when you do these problems, don't go too fast. They are deceptive. They seem very easy, but they're actually not. So, the first thing I want to give you is what we call the product of powers. Now, you don't need to memorize this rule in these exact terms. I don't care if you know that this thing is called the product of powers. The main thing I want you to be able to do is understand what we're doing. So, for this one, when we have two things with the same base, and here our A is called our base, and we have two things being multiplied, this m is our exponent, and so is that n. So when you have that, what's going to happen is our base is going to stay the same. It's going to still be a, or whatever variable or number you have, but the m and the n, the two exponents, are going to be added together. I actually wrote it out in words on the side. When you're multiplying two things with the same base, keep the base, add the exponents. So it's hard to understand when you're just looking at rules, so we're going to go through some examples. And I'm going to actually show you two ways to do these, a short way and a long way. Now, the long way I don't recommend doing after the first time, but it's a good way to see what's going on. So here I have 2 to the 5th times 2 to the 3rd. I am asking you to simplify, not to solve. So we're just going to simplify. And when we simplify these, what we're going to do is we are going to keep the base the same. It's still 2. We're going to do 5 plus 3. 5 plus 3 we all know is, or at least I hope we know, is 8. And that's actually my answer. By the way, you can skip that middle step if you want to. You don't have to write the 5 plus 3. I know you guys know that 5 and plus 3 is 8. But if you want to write that, that's fine. The one thing I would really like to caution you about is the number one wrong answer. A lot of people like to multiply these 2's together. They see a multiplication sign, they see 2 times 2, they write 4. Unfortunately, that is the wrong answer. So just be very, very, very careful. Now, the thing I just showed you right here is our short way. I'm going to show you the long way for one problem, and it's going to be this one. So in this problem, we know that 2 to the 5th is the same as 2 times 2 times 2 times 2 times 2. You can see already why this is called the long way. We know that 2 to the 3rd is, we're multiplying it by that, by the way, 2 times 2 times 2. And if you look in the end, we can actually rewrite this whole entire long thing as 2. There are 8 2's there to the 8th. And that's the long way to do it. This is actually a great way to do it if you want to teach like your 5th grade brother or sister how to do exponents, because then they can see it, they can just count the 2's. Once they're in 7th grade, 8th grade, 9th grade, probably better to do it the short way, especially when you get like 2 to the 50th. You don't want to be writing down 52's, but it's a good way to see what's going on. So I'm going to give you a few more examples, and I'm going to ask you to try those on your own. By the way, you're still simplifying, you're not solving, and I'm actually going to give you a few that have variables, a few that don't have variables. It'll be good practice. So if you want, you can pause and try these. If you're still not sure on some of them, 4 and 5 are a little harder. You can just watch me do them, up to you. So on number 2, I'm going to recommend that you do it the short way. You're going to keep your base as W. you are going to add your exponents. 10 plus 7 plus 2 is 19, so that is my answer. Very fast problem. 3 is also fast. The one thing I want to caution you against is mistake people like to make is they like to do 16 to the 11th, which is very wrong, so please be careful about that. The other thing people sometimes like to do is they like to multiply their exponents. Also not the right thing to do, so just make sure you're adding your exponents. So now 4 is a special type of problem because our second 5 has no exponent. However, if you remember, when we have just a 5, it actually does have an exponent, it's just like an invisible exponent. So that's actually the same as 5 to the first power. So what's going to happen is we're going to add our exponents, we just end up with 5 to the 4th. Number 5, it looks really hard. It's actually the exact same type of problem as the previous ones. Our base is this entire -6. The negative is included. So what's going to happen is we get -6, and it's going to be to the 18th power. Similar to all the other types of problems that we had. So we have 2 more properties. Our next property we call the power of a power property. And it's kind of confusing sounding, but once I do a few examples, it's not so bad. So our rule for this is that if you have something that's raised to an exponent and the entire thing is raised to another exponent, you are actually going to multiply your exponents. So in this case, my base, the a, stays the same, but now I have a to the n to the m, I multiply my exponents. So an example would be if I have 5 to the 2nd to the 3rd, this is actually the same thing as 5 to the 2 times 3, which gives me 5 to the 6th power. Now, a lot of people confuse this one with the previous thing, so I'll just write off to the side. Our previous property, it looks really, really, really similar, but there is one slight difference. So the previous property, it would have been written as 5 to the 2nd times 5 to the 3rd. You'll notice that we have 2 exponents, they both have a base of 5. That one we would have added. So just keep that in mind when you're doing these. Make sure you know which property you have to use. Make sure you know if you have to add or multiply. So let's do a few more examples. If you want, you can feel free to pause and try these ones on your own. However, I am, just for the fun of it, going to toss in one that always, always, always confuses people. That's a z, by the way. But go ahead and pause if you want to try them. Okay, so number 6 is similar to 5. We keep our base of n. We have n to the 7th to the 2nd. We are going to multiply our exponents. That gives us n to the 14th. Make sure that you did not add those. You would have added them if it was like the previous one where we had n to the 7th times n to the 2nd, but notice how we did not have that. We didn't have 2 of the same base being multiplied. 7 is similar. The only thing that's there that's meant to kind of trick you is that negative. However, our entire base is -3, so we keep that the same. And then we multiply our exponents. It's going to be -3 to the 15th. So now number 8 is one that in general will always confuse people the first time they see it. I might put one of these on a quiz. It's not a huge thing. There might be one on a homework. Don't freak out if you're a little confused on it. We're going to do a lot more with this stuff later, and even more when you get to Algebra 2. But for this one, our entire base is the z minus 4. So what happens is we keep z minus 4 as our base, then we multiply our exponents. We get z minus 4 to the 10th. Our last property of this lesson is called the power of a product property. Once again, you do not need to memorize these names. They are so hard to remember. So if you don't remember what they're called, it's fine. Just make sure you can use them. So for this one, I like to call it the distributed property of exponents because what we have, if you have two things being multiplied that's raised to an exponent, you actually can take that exponent and raise everything inside of the parentheses to that. So you'll find that if you have something times something else raised to a power, you're going to end up with a to the m times b to the m in this case. So I'll give you a few examples. And let's start with one that has a number in it, just to make it more fun, but also variables. So I have 2 times x times y, and it's all raised to the 3rd power. So in this example, what we're going to do is we're going to take this 3, the y is going to be to the 3rd, the x is going to be to the 3rd, and do not forget the 2 is also to the 3rd. The reason I say do not forget is because I see a lot of people mixing that up and forgetting the 2. So what we're going to do is we're going to write this as 2 to the 3rd times x to the 3rd times y to the 3rd. And whenever you have something raised to an exponent that's a coefficient to variables, I would like you to actually simplify it. So this 2 to the 3rd, you can simplify. If you don't remember what 2 to the 3rd is, feel free to multiply it off on the side. 2 times 2 times 2. It's 8, by the way, not 6, so just be careful. So you get 8 times x to the 3rd times y to the 3rd, and that's my answer for that one. The second type of this problem, it's a little harder. However, if you would like to try it on your own, feel free to pause and try it. If not, that's okay too. So for this problem, it's a similar idea. I am going to take this 2. Everything inside is going to be raised to the 2nd power. So I'm going to end up with 5 to the 2nd. So now, in this part, people sometimes get a little confused because we have x to the 3rd to the 2nd. But remember, if you have a power raised to another power, we actually are going to multiply our exponents, so it will become x to the 6th. Then I have y to the 2nd. Last step, as in the previous one, is to multiply the 5 to the 2nd. It's 5 times 5. And this is my answer. So here we have 3 more problems using all 3 properties. So 11 and 12 are normal problems. 13 is a sticker problem, so I'm not going to give you the answer for 13. However, if you feel like you're good at these and you have a little bit of time to maybe work on it, you can try this once you are sure that you're good with 11 and 12, and you can show it to me tomorrow in class, and if you get it right, I will let you take a sticker. But before you do that, I want you to try 11 and 12. If you feel comfortable with these, if you think you can do putting several properties together, go for it. Try it on your own and pause the video. If not, I'm going to do them right now. So for number 11, there's a few things that you can start with. But the first thing I want you to notice is that this 2 goes with all the stuff in these parentheses here. So what's going to happen is I am going to keep the x squared the way it is. I'm not going to touch it. From there, I am going to change this to 3 to the 2nd times x to the 6th, multiply your exponents, times y to the 2nd. From there, I can put together my x to the 2nd and my x to the 6th, and I can also make my 3 to the 2nd a 9. X to the 2nd times x to the 6th is x to the 8th. Y to the 2nd doesn't change, and that's my answer for 11. So then number 12 is actually slightly easier, other than the fact that 3 to the 4th is a little bit of a high number. So I'm going to distribute this 4 as the exponent to the 3 and to the y. And 3 to the 4th, if you aren't sure about it, feel free to work it out on the side. We know that 3 times 3 times 3 to the 4th is 3 times 3 times 3 times 3. So 3 times 3 is 9. 3 times 3 is 9. So that's going to give us 81. Feel free to work that out if you want to. Don't just go straight for the calculator. And we have y to the 4th times y to the 5th. That is just going to give us y to the 9th. So our answer, of course, is 81 times y to the 9th. So once again, 13, if you want to try for the sticker, go ahead and give it a try.